Hello and welcome to another video from Between CAD Classes. Today I'm doing another Too Tall Toby challenge. The goal is to see how quickly I can model these three parts, in my case using Autodesk Inventor. If you haven't checked out Too Tall Toby, please do so. I'll put a link down in my description. Really fun contest to see how quickly you can model things. Before I jump into my submission, I do want to point out that speed modeling is a blast. I love it. I do find myself modeling things in a certain way that I would never model a final part because of the way the sketches are created and the design intent. The goal of the speed modeling is to get it done as quickly as possible, not necessarily worry about how nice of a model am I passing on to the next person. With that said, I use a lot of techniques to go as quickly as I can. I hope you enjoy this video. Again, check out the link down below if you want to see the other contestants and Too Tall Toby's channel. Let's jump into my submission. Alright, so here I am in Inventor 2023, and I'm going to begin with this first part that is an English unit part with plain carbon steel. And what I've done is I've created some templates ahead of time that use the particular materials that Toby wants. So here I'm starting with a specific template. And I'm going to begin by creating a couple of overlapping rectangles. Honestly, this is probably not how I would normally draw in a day-to-day basis, but for creating quick parts, it's a really quick way to create the shapes. So here I am extruding, switching to the mid-plane option because I know I've got a rib running through the middle. Now I'll sketch on that middle plane here and slice graphics, project my geometry, and create the rib shape. And then of course add in the necessary dimensions to get that fully constrained. Then I'll go ahead and extrude this also mid-plane, this time only 1/4 of an inch here. Then I'm going to add in the angled cut on the bottom. I tried this a couple of different ways. I tried it from the side. It took a lot of sketching. I figured out if I created a rectangular shape and extruded it as a cut with a 30-degree angle, I was able to get this feature done a heck of a lot faster. Then placing some holes on top. Again, I found that if I created a construction rectangle with the endpoints where I wanted the holes, I was able to locate the holes much faster. Probably not how I would do it in everyday modeling. I'd probably go ahead and add the individual dimensions and maybe some constraints, but again, for speed modeling, works really well. Last thing is adding in the chamfers, and we can see that I have the correct mass there of 2.44 pounds. So moving on to the next part. This was a metric one, and I did this one as a revolve. It could have been done as some circular extrusions, but I found the revolve to be quicker. Once again, I create a couple of overlapping rectangles to draw this as quick as possible. Then I'm adding in a circular feature here that's going to be cut out. Rather than doing that in a separate feature, I put it all into one sketch, again, to make it as quick as possible. If I'm modeling day to day, I'm probably making that a separate feature so that I can suppress it or get rid of it if I want to. Next, I'm creating a rectangular cut on the top of this part using the center point rectangle to locate it. And then I'm going to cut that down 34 millimeters in, and once I've done that, I got some holes on the outside, so I'm using the plane tool to create a plane parallel to that first one and tangent to that outer one. Once again, projecting geometry and using a rectangle to locate where the centers of these holes are going to be. I use the shortcut H on the keyboard to jump me into the hole command, and then of course I put in the values for these particular counterbore holes. That's the last feature, so I use my I shortcut to get to I properties so I could take a look at the proper mass that I had for that one. This last one's also metric, but with an alloy material. I do a lot of sketching in this first sketch because it's just simply faster instead of creating multiple sketches. Again, in a day-to-day modeling situation, I'm probably creating each of these as their own sketch, their own feature, because it makes a more robust model that's easier to go back and modify. But for speed modeling, I'm putting a lot of things into one sketch here. Added a vertical constraint right here to line this up symmetrically. Then I extrude. I created a keyboard shortcut on my Inventor of V for visibility. And I'll go ahead and extrude that up, hide my sketch, add my counterbore hole here, again putting in the values, and then I will fillet these front two corners And that pretty much takes care of the base feature. Then I sketched from the side to create the raised feature. Now, there might have been other faster ways to do this one. My method was to create the rectangle and then to draw in the angled line across. I found that to be fairly quick for me. Then I extrude and then flip the direction to get it to line up. Then the last thing I have is a cutout and a couple of holes. So I do this all in one sketch. Again, probably not what I'm going to do day to day, but for speed modeling works pretty well. So I'll use that to locate my two holes, and then I'll create a slot shape for the cutout. Then I will finish my sketch and add in the two holes, putting in the values here for the counterbore holes, and then once again using that V shortcut for visibility so I can bring that sketch back, and then extrude these cuts and properties and finish at 4:39. So pretty happy with my time. I could probably shave a few seconds off if I continued to practice, but at some point I gotta stop playing with these models and move on with my life. So I hope you enjoyed this video. Again, check out the links in the description to Too Tall Toby. You can check out his leaderboard, see how I'm doing, and of course try it yourself if you want to see how fast you can model these 3 parts. Thanks for watching.